All right, let's go ahead and get started. Any questions before we get back into parametric curves? All right, so a couple of quick reminders about things. I think I mentioned last time that the next test is the 20th, so a week from today. So that'll cover basically from section 8.4 up to 9.2. We're on 9.1 right now, so I'm going to try to leave as much as I can, as much time as I can for Friday to be review. Kind of the same way we've done it before. So whatever questions you have, we'll go over whatever you want. But we'll stop after 9.2. Also, I got word they started assigning rooms for the final exam. It will not be in here. It'll be in the engineering building, the G wing of the engineering building. So just keep that in mind. I'll give you a reminder as we get closer, but we won't be in here. What else? I think, go ahead.
Do you mind just what day?
Yeah, so let me look. I know it's Thursday of finals week. I can't remember the date, so let me look that up. Thursday the 7th. So Thursday, December 7th at 7:10 p.m. It's ECG 347. So I mean, I don't expect you to commit that all to memory right now. I'll give more reminders as we get closer. That's a little less than a month away. Anything else? Okay, so let's get back into it. So been a long weekend, but basically kind of catch you all up. What we talked about in this section so far is these new kinds of curves that, you know, this thing we graphed here, I guess I'll just ask this question now, is the thing we graphed a function? And in that case, it kind of depends on how I ask. Is y a function of x? So I can't say that, but when I asked if it was a function, a lot of you nodded your heads yes. So in what way is this thing a function? How else can we view this thing to say that yes, it is a function? So basically, what's the input and what's the output?
T is the input for x and y value.
So t is an input, and then for any given t value, you get a point. So if we treat this thing that way, then yes, that we can treat this as a function. For any given t, I'm going to get one unique x value, one unique y value, and then that combination will be unique. Okay, so this thing here, I would like to know what this looks like. So how can we answer that question? So I have an expression for x and y in terms of t. I'm giving you an interval where t is defined on. Basically, I'm giving you a domain. How can we find out what this thing looks like?
Table.
Table? All right, what are some sensible values to choose? Straight lines are hard. All right, throw me some values I can plug in. 0 is always a good choice. When t is 0, what are x and y? What's that? Yep, 1 and 0. So I think that here's a point. All right. Do we know what this curve looks like yet? Doubtful. So what else can we try?
Pi over 2.
Pi over 2. I heard pi over 2 and pi. So when pi over t is pi over 2, what do I get? What's the cosine of pi over 2? 0 and 1. Okay, so I got another point. How about for pi? -1 and 0. We have an idea yet? So if I graph these in order, so this will be point A, point B, point C. Is that enough for me to have any suspicion or guess what the what this curve is going to look like.
Maybe 3 pi over 2.
Let's do 3 pi over 2. And what values for x and y do I get there?
0, negative
0, negative 1. All right. So what did do we need more points or we have an idea? If I connect these in the order in which they show up, if you use your imagination, what is that? It's a circle, right? So we made a circle. Let's be specific about what the circle looks like. If we can, I think we can uniquely define a circle by where its center is. So where is its center? 0, 0. And what is its radius? Radius is 1. Okay, so essentially we made the unit circle. Which I don't think we've talked about it much in this class, but I know it has come up. This is kind of the definitions of what cosine and sine are, right? If you have an angle, in this case, we're calling an angle t. If you take the cosine of that angle, you get the x value of the point that gets projected onto the circle. A similar definition for sine. So any questions about how we built this circle using that parameter t? So I think, again, this is not, the y is not a function of x here, but now bringing in that parameter, we can treat that as a function. Go ahead.
Do you even draw arrows?
That'd probably be helpful. How so? Like, what do the arrows indicate for you?
The direction that the graph is going.
Okay. So this circle is graphed. How would we describe this? Counterclockwise? Counterclockwise, anti-clockwise? But I think those three descriptors right there, you kind of uniquely define the shape. I think we're good. Questions? All right, moving on. So what changes have I made here? So I'm still graphing, x is still a cosine function, y is still a sine function. They have the same argument, basically. They still have, it's not t anymore, but they both have that argument of 3t. Do we think this will still be a circle? Bigger? Bigger how? What would the radius be?
Nice.
Oh, I heard a vote for 2 and a vote for 6. So let's talk. I changed 2 different things, right? I made the cosine and sine. I changed their coefficient to be 2. I also changed the coefficient of t from 1 to 3. So yes, this is still a circle, but let's try to figure out what changes happened. So with our last, set of equations, one thing we talk about with, or what we can talk about with sine and cosine, is their amplitude. What does that mean? What does the amplitude of a sine wave or a cosine wave refer to? Yeah, so basically, from the middle to the top or the middle to the bottom of it. Basically, how far, or another way to think about it is, at most, how far does your curve deviate from the middle? So what was the amplitude on this one? On these two? The amplitude's 1, right? What would the amplitude be here? 2. So if the amplitude of these two x and y functions is 2, what does that do to our circle? Expands, what part, what, like, specifically what about the circle? Gets bigger. The radius, okay. I know it's in your head, Sarah. I was trying to coax it out, but yeah, so the radius is going to be 2. Do we believe it'll still be centered on the origin? Or do I need to defend? Do I need to defend why I'm drawing this around the origin? So we said the amplitude of cosine and sine of these cosine and sine waves were 2. But does that mean their center line is 0? I think it is. I think this radius should be 2. So I have a circle centered at the origin with a radius of 2. Our last one was graphed counterclockwise. How about this one? Do we agree with the counterclockwise again? Let's try to figure it out. If t equals 0, then what point do I have? 2, 0. Okay, so I think we can call this a reference point. Positive x-axis. Do we have any idea what the effect of that 3 is? Because I don't, in the graph I've drawn, I don't see how that 3 changed anything about this circle.
Well, it changes the t values. You can use like pi/6 to represent like sine of pi/2.
Okay, so if I choose t equals pi/6, which was not a t value we just used, what point do I get out of that? 0 what? 2? Okay. So does that give you enough information to tell you how this thing is graphed? Is it counterclockwise still? Should be. But one thing we didn't do is this. I gave an interval 0 to 2 pi for this circle, right? So let's try to make an interval here. And let's do this. I want to make this interval as small as possible. And what I mean by that is I want to draw the whole circle, but I don't want to redraw any of it. So yeah, I'd like to start at 0. Like, what's the last value of t that I would need to graph here to get the whole circle? Go ahead. How'd you get that?
Because we're trying to get to the 2 pi value, but here 3 p divided by 3.
Right. So do we have an idea of what that 3 really altered here? I don't think it had any effect on what xy values get graphed. I don't think it had any effect on of how the shape, like the final product, looks. But if you think back to the way we graph these things, let's just pick one. If I say y equals sine of t and y equals sine of 2t, what's going to be the difference in how these two graphs look? Presumably most of you are engineering majors, so can I talk about the frequency of these graphs? Which one's going to have a higher frequency? 2t, right? You've probably also heard this as frequency is tied to something called period. So basically, we don't have to be talking about time here, but basically think about it that way. How much time does it take for you to do one full behavior? So I multiplied this variable t by 3. So what did it do to the period? It cut it down to a third of what it was, right? Does that make sense?
Yeah.
Okay. Question?
So should we find these bounds first before we start plugging in values?
Yeah, I mean, well, you can.
Because otherwise, like, if we plugged in what we did last time, pi/2, pi/2,
It probably would not have been clear.
we get the same thing, but we get it going clockwise.
Oh, is that what you did? So if t equals pi/2, then what do I get? Yeah, then that's going to give you the 3 pi/2 point, right? That'll give you, oh, wow. That should give you 0, -2. So yeah, if you plugged in those 2 points, then it's going to look like it's graphing clockwise for sure. So yeah, finding those points is probably a good idea, like setting those bounds. But one thing I wanted to emphasize is that, having those cosine and sine functions being governed by the same parameter, that's going to yield a circle. One last condition to worry about here is these arguments have to be the same. How are we doing? There's one more thing I need to point out. One more condition I forgot. What would change here if this was a 2 and let's say this is a 4? Would that still make a circle? Do we know what the thing is called that would make? It's an ellipse, yeah. So basically, yeah, if you make one of the, so an ellipse it has a lot of same properties as a circle, but it has 2 different radius values. So changing that value would make an ellipse. How are we doing? Okay. So I want to find a Cartesian equation for this. So basically, what does a Cartesian equation look like? Those look like y equals, some function of x. So these are the things that you're probably most used to. So basically what I want to do here is I want to eliminate that parameter t. So I want to figure out what this curve looks like and then come up with an equation for that. So do we have any idea what this curve looks like? Do you think you can say that it's circular? Okay, so I have sine waves. I have sine wave and a cosine wave. They are both have the same amplitude and they have the same period. So I believe I have a circle. So if we think we have a circle, then we should be able to figure out what the radius of that circle is and what the center of that circle is. Any ideas on how to figure that out? So we have a bound, we have an interval for t. So yeah, we have something circular to think about, but how do we start figuring out what the circle looks like? Think back when you first started learning how to graph things, what was like the most basic low-tech thing you could do if you did not know what a function looked like? Plug in points. So what are some points I can use? I'm just going to use let's just start off with the 3, vertical lines. So let's just stick with the quadrant angles, pi over 2, pi through pi over 2. Hopefully that helps. When t is pi over 2, what do I get? $6.12. And then pi, I should get 1.7. And 3 pi over 2, I should get 6.2. Yes? Yeah. Okay, so now I can graph those. Am I totally in the first quadrant? Four, 6, 8, 10, 12. Okay, so these hash marks represent 2s. So 2, 4, 6. So that's my first point. Second point. Okay. So is that the whole curve or part of it? How are we doing? So it should be the whole thing, right? Just the left half of the circle. Where's the center of that circle? 6 what?
6, 7.
6, 7. Does that make sense with the equations you're looking at? Think back when you learned how to graph trig functions, sine and cosine waves a while ago. How do you find the center line? So let's just look at one of these. If I were to ask you to graph x equals 6 plus 5 cosine t, how would you know where the center line is? Like that average vertical value. Or is that too long ago to ask about? So let's build it up again. Amplitude you seem to be comfortable with. 5 cosine t. What are the lowest and what are the smallest and greatest values that can come out of 5 cosine t? Negative 5 to 5, right? So basically, I'm going to add 6. So basically, at least this is going to be negative 5, right? So 6 minus 5 is 1. We found that bottom value. And at most, this is going to be 6 plus 5. That's 11. What's the midpoint of 1 and 11? 6. So the center value always comes from whatever your constant is. So we got a center of 6, 7, which directly reflects our center values of our individual x and y variables. So I said the highest value of x was 11. We don't see that, but why don't we see that? Right. But if these are trig functions, like these cosine and cosine should go through a full, they should be one amplitude away from the center and at some point be one amplitude below. But for the x equation, I don't see that we ever went above 6, right? Why didn't we?
The domain.
Yeah, the domain prevented that from happening. So we're not looking at a full sweep of angles around the unit circle. All right, so we have a center of 6 and 7. What's our radius? Could you have predicted that from the equations? So I think the center and the radius, like if you kind of have an idea what you're looking for, those can all come from those equations. Do we remember how to find the equation of a circle in x and y? So I think we've done it before here, but it was very brief and it was probably a while ago. What's the definition of a circle? What makes a circle different from all their shapes? Right, so no matter what points I choose out here, it's the same distance from the center. So where's our center? That's going to be 6. So this distance x minus 6. This distance right here is y minus 7. And this right here is my radius, right? My radius is constant. That's just 5. So I think I can make an equation here. I know that from Pythagorean theorem, x minus 6 squared plus y minus 7 squared is equal to 5 squared. So first of all, does it make sense how we built that? Does that look familiar to? I'm promising you've all done that. It's probably somewhere in your first half of high school was the first time you did that. But now that we have that, now we want to make a Cartesian equation. So I want to solve this for either x or y. So the thing we graphed is y a function of x? No, is x a function of y? So let's go ahead and solve for x then. So if I start manipulating stuff, I get x minus 6 squared equals 25 minus y minus 7 squared. X minus 6 equals, well, I took a square root, so I better do plus or minus the square root of 25 minus y minus 7 squared. And then x equals 6 plus or minus the square root of 25 minus y minus 7 squared. But this isn't really a function because this has a plus or minus in it. So I think this would really, if I really did both, like the plus and minus here, I would get a whole circle. So what can I do here to just graph the part of the circle I really want? If I did 6 plus whatever's in this square root, what am I going to get?
Number larger than 6.
You're going to get numbers larger than 6, right? Do we want that? So I think we just need to eliminate the plus, and this right here is basically what we graphed. So basically, if you let y sweep out the values that it can take, then you'll get that left half of the circle. How are we doing? Questions? Okay. So there are lots of ways to, this kind of exercise right here is called eliminating the parameter. We started with two equations that were joined by some parameter t, and we basically, in a roundabout way, eliminated that t and just joined x and y. So there are other ways to do that. So we're not going to graph this one, but what I want to do is I want to get an equation here that's Cartesian. So either x is a function of y or y is a function of x. Any ideas on how we can do that? So we're not going to graph this one, but I don't know if the graph would help us much anyway. So our goal is one of these things, x equals f of y, or y equals f of x.
We start plugging in points.
No, so we could, but like I don't think knowing what the graph looks like is going to help much. So our goal here is to get rid of t, right? What if we solve one of these things for t? Let's say we were able to do that. Like, let's say this. Let's say maybe we would get t equals g to the y. Would that help us accomplish the goal we're trying to accomplish? So let's try to do that. Your pick. We're going to solve one of these equations for t. Which one do you want to go with? There are no wrong answers. X sounds good. I want to solve this one for t. So let's start doing that. How do we get there? Okay, so I get x plus 1 equals e to the t. And then? Right, so the natural log of x plus 1 equals t. So we got one of them solved for t. What can we do with that now? Plug it into y. So y equals e to the what? There you go. So have we accomplished the goal? I think we have. There's no parameter left in that equation. Can we simplify it a little bit? How so? Can't really cancel the e in the natural log quite yet. Go ahead.
You can take the 2 and put it above the x plus 1, so you're raising x plus 1 to the 2, and then you take this plus the e.
Right. So that is legal to do. And now what we can do is see this y equals x plus 1 squared. So, I mean, we accomplished the goal a couple steps before that, but yeah, this is comes out to an equation that doesn't involve exponential functions at all. Questions on how we did that? Do I have you do another one? Yeah, let's look at this one here. So eventually I want to sketch and identify this curve here. So yeah, like we've done with the last few examples, we picked a bunch of t values and plugged them in. But that's not always the best way to go. Is there any other? Go ahead.
But isn't y just x squared?
Isn't y just x squared? Does this make sense? How'd you do that?
Well, because x is sine of t and y times square of t, so you just square it.
So is it that simple?
I don't know.
What do the rest of you think? Is it safe to say that y equals x squared? Based on what I'm calling x and y. Yeah, that's absolutely true. So, and kind of these parameterizations don't make a lot of sense. I mean, if I have a curve y equals x squared, that's pretty simple to relate x and y to. That parameterization makes it a little harder to see. So do we know what y equals x squared looks like? Yep. So the parabola that has its vertex at the origin. That's not bad. I know you could plug in some values for t. I don't know how obvious it would be. Or I don't know if it would help you kind of get to where you're trying to go. So in the last few examples, we're looking at this idea called eliminating the parameter. I mean, I think just because of your experience, you're probably a lot more comfortable in looking at these, these equations that unite x and y directly. Any questions on the last couple examples here? All right. So a couple more things I want to show you because I know that WebWork is going to ask for them. So I'm giving you the Cartesian equation of a circle, but I want to parameterize it. And I've already given you half of the parameterization. So basically what I want to find is, my goal here is to find this. Y of t equals what? Any ideas on how to get there? What would you like to try? Munya? Let's try it. If I plug in that expression for x, then what do I get? I get 4 plus 2 cosine t minus 4 squared plus y minus 5 squared equals 4. So how does this one simplify here? Right, so 4 cosine squared t plus y minus 5 squared equals 4. So y minus 5 squared equals 4 minus 4 cosine squared t. Y minus 5 equals plus or minus the square root of 4 minus 4 cosine squared t. So I have a dilemma again. Y equals 5 plus or minus this square root. So there's a piece of information in this question that we haven't used yet. So I believe we have our correct answer written down. We just need to eliminate the wrong one. So we use this equation for a circle. We use this parameterization for x in terms of t. And we basically have two options for how to parameterize y in terms of t. So how do we choose the correct one? So maybe it would help if we draw this circle. Where's the center of this circle?
uh, 4, 5.
4 or 5? I agree. What's the radius of this circle? 2? How come? Why not 4?
Isn't it, x squared plus y squared equals y squared?
Yeah, it is. Okay. So here's my circle. But I want this thing to be drawn clockwise. So how can I make sure I'm going to do that? So I know this is my circle, but when I graph something in x and y, there's no, like, the directionality kind of gets hidden. So go ahead.
So the sine value has to decrease first before it increases. It's going clockwise, so it should be a subtraction sign.
The sine value, where's the sine value?
Oh, I guess, well, I plugged in a trig identity for 4 minus 4 cosine.
Okay, so that's helpful. So you said you simplified 4 minus 4 cosine squared?
Yeah,
What'd you get?
5 plus or minus 2 sine.
Can you explain how you got that?
You substitute 4 minus 4 cosine squared t for 4 sine squared t, and you can simplify the radical.
Right, so that's a Pythagorean identity that we can always use. Sine squared t plus cosine squared t equals 1. So maybe this will help a little more. So y is equal to 5 plus or minus 2 sine t. And Colin, you're saying that we want the sine value to, basically we want the y value to shrink. We want it to decrease before, at first, right?
Yeah.
We okay with that? So I think what Colin is saying is we should eliminate the plus sign and go with this. So let's try to convince ourselves of that. Let's plot some points, or at least 2. If t equals 0, we know where x is, right? We were given x. What's the x value that goes with x, or that goes with t equals 0? Be 6. And our y value, regardless of what side we pick, is going to be 5. So our starting point is here. Call that point A. One thing we should talk about now is what should our bounds be? So let's say that t is never less than 0, but how high should t go so I could sweep out a full circle and no more? Two pi. How did you come up with the number 2 pi?
Well, both x and y have just t in the function, so it's not being multiplied by or divided by any constants.
So what is the period for a sine or cosine wave? Like if it's just y equals sine of t. How much does t have to change by to do one complete cycle? 2 pi. So I agree with these bounds 0 to 2 pi. So let's choose the next quadrant angle over pi over 2. I know when pi over 2, x is going to be equal to 4. So I want point B to be down here, right? Because I want to draw clockwise. So that means I want my y value to be 2. Does that go with the y value that we have, or the y expression we have here, 5 minus 2 sine t? Yes, it does. Does that make sense? What do you get when you plug in pi over 2 for y here? Did I just say the wrong y value? Should be 3.
Yeah.
Don't assume I know what I'm talking about. We good there? Questions? Okay. All right, so I have a bunch of unknown constants. I want to find all their values. So basically, I want to find A, B, C, and D are all constants. I have enough information to figure out what they are. But how do I do that?
Make like one equation of x and y, like from the, like by finding the slope.
Oh, so you want to find, okay, so you want to eliminate the parameter, basically. Okay, so which one of these things do you want to solve for? Or, yeah, which one of these things do you want to solve for t in? Okay, so that gives us x minus a equals bt, and t equals x minus a over b. And then if I plug that into y, I should get y equals c plus d times x minus a over b. We agree with that? Now what?
If you find the slope, can we include it to x minus a over b?
If we find the slope, yeah, what is the slope of this new equation we just made?
Minus a over b.
I don't think the slope is x minus a over b.
Well, if we expand it, it's d over b.
So y equals c plus d over b times x minus a. So we can find the slope between 1 and 1 and negative 2, 4, right? What is the slope?
So
4 minus 1 over negative 2 minus 1. So what did that teach us about d and b?
one of them's 4 and the other is 4. They're equal.
Not equal. Equal and opposite, so equal in magnitude, but
Yeah.
opposite in sign. But does that tell you what d or b is? So I agree that, so I mean, this,
I do know d equals negative.
we know d equals negative b, right? Okay, so basically we have gotten from 4 unknowns down to 3 essentially, because these two are kind of tangled in this way. All right, what else? Any other ideas? Let me ask you this question. If t equals 0, what does that mean about x and y? They're both 1, right? So can't I say, can I say anything about, can I say
Yeah, because. And C plus one, is if T equals 0. Like it's T times 0. So you get Y equals C.
Right. And I think by the same logic, I can say that A equals 1, right?
Yeah.
Okay, so I think we got two of the unknowns because we know that when we plug in 0 for T, that's going to annihilate basically B and D. So we know that basically the values of A and C come from where this curve starts. But now can I get B and D? And based on what we've already done, I think if I find one of them, I got the other. So how can I find one of them?
Use the same logic with T equals 1 and the point equals 2.
Okay. So if that's the 0.24, let's just pick one of the variables. X is equal to A plus BT, right? Or A plus B. And that's equal to -2. But I know what A is, right? So 1 plus B equals -2. So what's B? -3. Which means D is what? 3. So one thing I want to point out here is we're so used to thinking about slope as this change in Y over change in X thing. But let's try to generalize slope a little bit. Slope is a rate of change, right? It's an average rate of change. So we called this a delta Y over delta X. But what if we talk about these slopes? Delta X over delta T and delta Y over delta T. Can we find those? I mean, I think we already have, but could we have found that at the beginning?
Yeah.
What's the change in X over this interval?
-3.
-3, and the change in T was 1. Can I say that these slopes right here are constant? Based on the way X and Y are defined, can I say those are constant or just averages? How do you know?
Because B and D is, or D is a constant. And D is a constant.
Right. So another way to ask this, if I were to just graph like X versus T or Y versus T, what would that graph look like? Straight line, right? So if they have a straight line, then I could think I could say, yes, those are constant rates of change. So this is a very short kind of like sample of what we're going to look into next. So I'm not going to get too deep into it. I just want to kind of mention what we're going to do on Wednesday. But we talked about kind of how to think about parametric curves. The next section is all about how to perform calculus using them. So I'll just ask this question quickly. What does a derivative of a function tell you? I heard the word slope. I heard the word rate. All those things are kind of, depending on how you look at it, they're all kind of true, right? They're all true depending on how you want to look at it, but they give you a rate of change, right? But they give you a rate of change of some variable with respect to another. That's usually the rate of change of Y with respect to X. So basically, when we get into parametric equations, we're going to talk about different rates of change and how they all kind of work together. But we'll get into that more on Wednesday.